Division algorithm 3. Suppose that we have these numbers now. 364 divided by 5. This is the dividend, 5 the divisor, the division block, this goes here, that 5 goes there, the quotient goes up. Now the new idea. Here we know that the dividend is a 3-digit number, so the quotient is a 3-digit number. But it can be a 3-digit number or less. Let's see why less. Look carefully, you have here 3. The dividend starts with 3, and 3 is less than 5. If you want to find 3 in table of 5, you will say that 3 is between 0 and 5, and you will take the 0. The quotient will start with the 0. When a number starts with a 0, we can cross the 0, and the number will be a 2-digit number instead of 3. So your quotient will be a 2-digit number. So whenever you have the first digit, a dividend with the first digit less than the divisor, the quotient will start with a 0. This is why you will cross a digit, okay? So instead of having a 3-digit number, you will have a 2-digit number, and you will say that your quotient will be a 2-digit number, not a 3-digit number. This is the first way. You can start with a 0 and cross it when you finish, or you will take 36 instead of 3. Just in the beginning, you are allowed to do this. Whenever you have a dividend whose first digit is less than the divisor, you can start with 2 digits, not 1. You take 36 instead of 3, and you will repeat the steps 2 times instead of 3 times, okay? The first time for 36, the second time for the other digit, which is 4, okay? And the quotient will be a 2-digit number, not a 3-digit number. Let's see, let's divide. Find, okay, you will write the times table on the side, or you know it mentally, and these are the steps: find, multiply, subtract, bring down, like father, mother, sister, brother. Let us start with the first step. Let's find 36. In table of 5, 36 is between 35 and 40, so we take 35. Now multiply means to write 7 up and 35 down. Subtract, we get 1. 36 minus 35 is 1. Bring down the 4. Now you will have 14, and you will find 14 in table of 5. We don't have 14, we take 10. Write 2 up and 10 down. Subtract, and you get 4. Can you bring down? No, no more digits, so we stop. Now 72 is the quotient and 4 is the remainder. You see how the quotient is a 2-digit number? Although the dividend is a 3-digit number, but the quotient is only 2-digit number, okay? Because we start with 36 instead of 3. So we write 72 up or 4, and if you want to write the Euclidean form, this is the Euclidean form: 5 times 72 plus 4, and the golden rule: 4 is less than the divisor, remainder less than the divisor, okay? Now, if I want to ask you to guess the number of digits in the quotient without dividing, just look carefully, look at the dividend, and try to guess the number of digits in the quotient. The dividend is a 3-digit number. But what can you notice? 4 and 3. Compare 4 with 3. We notice that 4 is greater than 3, so the work is normal. We divide, and the quotient will be a 3-digit number like the dividend. Excellent. Another example now: 486 divided by 7. Can you guess the number of digits in the quotient? We compare 4 with 7. Yes, 4 is less than 7, so the quotient will be what? Okay, we take 48. Yes, we take 48 instead of 4 because 4 is less than 7, and the quotient will be a 2-digit number. Yes. Now let's have these examples. Quickly, we will guess the number of digits in the quotient: 7,534 divided by 8. We will compare the first digit with 8. 7 is less than 8, so we take 75 instead of 7, and the quotient will we cross a digit, we'll have 3 digits. Yes, it's a 3-digit number. We take 75. Here, 4 is less than 6, so we take 45 instead of 4. And we have a 3-digit number. Excellent. Here, 782 divided by 9. Compare 7 with 9. 7 is less than 9, so we take 78. We lose a digit, so the quotient will be a 2-digit. You see, I lose a digit. Here, 3-digit. Now, the quotient will be a 2-digit number. 907 divided by 8. 9 is bigger than 8, so I work normally. I take 9. So, the quotient is a 3-digit number like the dividend. Okay? Now, the second part in this dividend is problem solving. We have a problem and we will solve a problem using multiplication or division. Let's see. Mr. Ahmad has 128 flowers. So 128 flowers. He wants to make identical bunches. He's making bunches of 7 flowers each. So this bunch has 7 flowers. Okay, 7 flowers each. Each one has 7 flowers. We are making bunches. We are distributing flowers in bunches. Do we know the number of bunches? No. How many bunches can he make? We don't know how many bunches. Just we know each. So let's imagine that we have this bunch 7, the other bunch 7, etc. So, and the last one also 7. We don't know the repetition here, how many bunch. We don't know how many bunch do we have. Okay, so the question is how many bunches can he make? So this is not the multiplication, this is the division, because every time we are taking 7, 7, 7, 7, okay, the number decrease, not increase, so the number will be smaller. Okay, it is the division. We divide what by what? The big number 128 divided by 7. You will divide normally using the division algorithm on your copybook or Scratch, and you will find the answer. So after we divide, we get quotient 8, remainder 2. So here he will make 18 bunches of 7 flowers each. Okay, you see quotient and remainder. Now if I want to ask you more questions, for example, if I ask you, did he use all the flowers? You will say, no, because the remainder is 2. Remember, the remainder was 2. So, no. He still has 2 flowers. Another question. How many more flowers does he need to make a new bunch? We know that we have 7 flowers in each bunch. 2 flowers are left. So how many more flowers does he need? We will say 2 plus what is 7? 2 plus 5, yes. So he needs 5 more flowers to make a new bunch. Now, another question. If he sells each bunch at $10, how many dollars will he get? So here we have 18 times 10 equals 180. It's a multiplication because I'm repeating. Okay, there's a repetition. I'm repeating $10 18 times 10. So we get $180. That's it. Thank you. Thanks for watching.